Okay, now here's a question. Given function f of x such that the first derivative of x with respect to x is the f of x square. Okay. Now I can write x2 here, right? But just to avoid the confusion with the derivative, so let me write this way, okay? The f of x square is equal to f first derivative of f of x. Now, if the nth derivative of f of x exists, find the nth derivative of f of x. That's the question. Okay. I think, I hope the introduction is clear. Now then, how do we start? We're looking for the nth derivative of f of x. And suppose it exists, right? Now, since f prime of x is equal to f of x square, then f double prime of x, which is equal to the derivative of f of x with respect to x, which means the f of x square derivative, isn't it? This is the first derivative, this is the second derivative. So this one is equal to 2 f of x times the f of x derivative, isn't it? So this one is square again, so the 2 times f of x 3. Okay, that is the second derivative. Now then, a third derivative is equal to, this is second derivative. Taking derivative again. Okay. Derivative. Wow. It's this is equal to 2 times 3, right? Times f of x square times the chain rule, right? Chain rule, the f of x derivative, right? The chain rule. So this one is equal to 2 times 3 times f of x square. This derivative, according to the given condition, that is f of x square, right? So together is 2 times 3 times f of x fourth power. Now, well, can we suggest that the nth derivative of x is equal to n factorial times f of x n plus 1, isn't it? See? Can we claim that this is this, based on the observation of the, of course you can do one more, but this looks like that way. But no matter how nice, your observation is, your guessing, or without proof, it is just proposition, it's just claim. We have to prove it, before we consider that this is a conclusion. So how do we prove this one? Of course, we were using induction, right? Mathematical induction. So let's prove this, which is coming from our observation, from the calculations, right? Now the proof starts with n equal to k, right? When n equal to 1, sorry. n equal to 1, then the first derivative is equal to 1 times f of x square, right? That is true. True. Then assume, well, induction, the wording is very important. It has to be logical. Now, assume that it is true for n equal to k. Now, n and k are just positive integers. Then the kth derivative of f of x is equal to k factorial times f of x kn plus 1, isn't it? Yeah. Then, right? Then consider k plus 1, right? F over k plus 1 derivative is equal to is taking this derivative, right? K n plus 1 derivative. That derivative will be k plus kth derivative, which is equal to this is the k, right? Excuse me. This is k, yeah. When n equals to k, this is k. So this will be k factorial times k plus 1 times f of x k, right? K plus 1 minus 1 is k times the chain rule, the f of x derivative, which is equal to this is k plus 1 factorial. This will be f of x to the kth power. This derivative, according to our condition, is equal to f of x squared, right? So this is equal to k plus 1 factorial and f of x k plus 2, yeah. K plus 2, correct. So this means it is true. It's a true for n equal to k plus 1. So it's proved, right? It's proved. See, mathematical induction. The wording is very important, and you have to write. Your writing must be very strictly logical. And okay, this is a nice question for practicing the mathematical induction. Thank you.